Let's solve homework exercise number 8 from section 6.3. Two stadiums with the largest capacities are Marshfield Stadium and Bowden. The capacity of Marshfield Stadium exceeds Bowden by 7,385. Combined, they have a capacity of 210,355. Find the capacity of each stadium. Now the trick here is, usually these problems are easier to solve or set up if you let X be the one you're comparing to. So Marshfield is you're comparing Marshfield to Bowden. So you're comparing Marshfield to Bowden. So let X be the number of people or capacity in Bowden. Okay? Marshfield exceeds Bowden by 7,385. So the number of people in Marsh is going to be whatever's in Bowden, which is X, right? We don't know. And then an extra exceeds is more. So we're going to add on 7,385. That's how many could be alone in Marshfield. Whatever's in Bowden, which we don't know is X, plus an extra 7,385 because it exceeds. Now, the two stadiums combine. So combine means adding, right? So Bowden is X. Marshfield is X plus 7,385. Notice you need two X's. One X here and another for X plus 3. The other X comes from the Marshfield, X plus 7,385. The total is 210,355. Okay? So solving, I can have 2X plus 7,385 is equal to 210,355. I would subtract 7,385 from both sides. Okay, so then this cancels. So I'll be left with 2X. Okay, so if we do that on our calculator, 210,355 minus 7,385. Okay, so then remember we were doing that. That just gave us, we had the 2X plus 7,385 is equal to 210,355. So when we subtract 7,385, then we get just, these gives us 0. 2X equals 202,970. Divide by 2, right? So we can't, so we reduce 2 over 2 is 1X is X. So 202,970, we have that there. Divide that number. Divide that number by 2. Okay, now that's X, right? Remember, X was Bowden. So Bowden has 101,485. Now, what was Marshfield? It was 101. It was what was in Bowden, which is 101,485, plus the extra what? Exceeds, so we add on 7,385. So its capacity is 870 seats. All right, very good. Homework exercise number 9. The average yearly salary, of a person whose final degree is a master's is 40,000 less than twice that of a bachelor's. A person whose final degree is a bachelor's. Okay? So now combine the two. They earn together 116. Find the average yearly salary of people with each of the final degrees. Now again, we're comparing masters to bachelors. So X is the amount of money earned by a bachelor's degree. Okay? Now, what's the amount of money earned by a masters, it's 40,000 less than twice that who has a bachelor's. So it's twice the bachelor's, 2x, but then it's 40,000 less, so minus 40. We'll do everything, we'll just go ahead and do everything in thousands, right? Because the number is in thousands, so we'll just use 40 to represent 40,000. So it's twice the bachelor's, 2x, and it's minus 40,000 less. Combine means you add them together, right? So x is the bachelor's, the master's is 2x minus 40 equals 116,000, or just 116. All right, simplifying, this is 1x, right? 1x plus 2x is 3x minus 40 equals 116. We would add 40 to both sides. So then this gives us 0, so 3x equals 156. Divide both sides by 3. Use your calculator if you need to, and it's 52. So x is 52. Now, the average bachelor's degree is x, right? So it's 52. The master's is what? 2x minus 40. So it's 2 times 52 minus 40. So it's 104. 2 times 52 is 104, minus 40 is 64. So the master's is 64, and the bachelor's is what? 52. Okay? So we'll put that in, 52 and 64. So the bachelor's was 52, and the master's we got was 64. All right, homework exercise number 10. According to the Center for Health Statistics in 1990, 28% of the babies in the U.S. were born to parents who were not married. Throughout the 1990s, this increased by 0.6 per year. If this trend continues, in which year will 70% of the babies be born out of wedlock? So where are we at right now? We're at 28%, right? What's happening? So we'll just do everything's in percent, so we don't need to include the percent, and we don't need to change. We'll just use the percent numbers. 28% now, so 28. We are what? Increasing by 0.6. Again, that's a percent, that's a decimal, so we need 0.6 each year. Okay, so x will be the number of years, that's what we don't know, after 1990. So it will be times x, the number of years after 1990, and then we want to know when is it going to reach, when will it equal, when will the percentage get to 70? So there's our equation. The percentage now is 28. We're adding on 0.6% every year, so x would be like 1, 2, 3, 4, 5, so on number of years, and we're going to equal, we've got 70 because we want to know when will the number of babies, the percentage be 70, born out of wedlock. So again, to solve this, here's my variable, so I'm going to subtract 28 from both sides. So these cancel, so I'm left with 0.6 times x on the left side. What remains is 0.6 times x. 70 minus 28, of course, is 42. To solve for x, get the coefficient 1, we would divide by 0.6. So then x is going to equal the whole number 42 divided by 0.6. Okay, if we do that on our calculator, 42 divided by 0.6, 42 divided by 0.6 is 70. Now, be careful, that's not our answer. X equals 70, which was what? The number of years after 1990, right? So in which year? So it's going to be the year 1990, and 70 years later, add 70. So it's going to be the year 2060, 2060. 70 years after 1990, because we started the process in 1990. So it's going to be the year 2060. Okay, we are going to stop this session right here. If you have any questions, send me an email at tswirs@hodges.edu or call me at 239-938-7805. Thank you.